This tutorial will show how to define and apply floor loads based on occupancy using the shell uniform load sets command. Shell uniform load sets allow multiple types of loads, such as dead and live, to be assigned in a single operation. This means that you can create occupancy-specific load assignments. For example, you could create one load set for office space in a building and another load set for a warehouse or storage space. For this example, we will assume that we are developing two load sets for a multi-story residential building. One to represent the load within the residences, and one for the load on the corridors. We will isolate a single story so that it will be easier to explain how we define and assign the shell uniform load sets. We start with just the beam and column framing, onto which we will add the floor slab. In this case, we will draw a total of 3 floor objects. The first floor object represents a corridor. The next 2 floor objects represent residential space. So that we can see the different area objects better, we will highlight the corridor. As previously stated, we will define one load set for the residences and one for the corridor. These load sets will contain 3 types of loads: dead, superimposed dead, and live. Reviewing the load patterns, we see that the 3 patterns have been defined. The dead load pattern with a self-weight multiplier of 1. The live load pattern, and a superimposed dead load pattern that will be used for miscellaneous loads like mechanical and plumbing. Now we define the shell uniform load sets. Clicking the Add button, we will name our first load set Residential. The first load pattern we will add will be dead, and it will consist of only the self-weight, so no additional load will be defined. The next load pattern used will be the superimposed dead, and for the residential space we will use 10 pounds per square foot. The last pattern in this set will be live, and we will set the load to 40 pounds per square foot. The next load set added will be for the corridor. Again, the dead pattern will be added with only the self-weight. The superimposed dead pattern will have a load of 30 pounds per square foot. And the live load will use a load of 100 pounds per square foot. We next select the slab objects that support the residences and go to the Assign Shell Loads Uniform Load Sets command. Here we select Residential and click the Apply button. Note that Residential is now displayed on the plan. With the form still open, select the interior floor object, which is the corridor, and highlight Corridor, and then click Apply. All of the floor loads have now been applied. Now let's verify the loads. First, we display the dead load. No additional loads are shown since this pattern is for self-weight only. The superimposed dead load shows 30 pounds per square foot along the corridor and 10 for the residences. And the live load shows 100 in the corridor and 40 in the residences, all of which are as expected. A right-click on the different floor objects confirms that the appropriate load sets have been assigned. Now we will run the analysis. Switching to a 3D view and displaying the moment in the slab, we can step through the results for each of the 3 load cases: dead, S-dead, and live. Note that the moments appear symmetrical for the dead case, but unsymmetrical for both the S-dead and live cases, as expected due to the different loading along the corridor. Thus, we were able to apply 3 different load patterns: a dead load, a superimposed dead load, and a live load to each floor object with a single assignment of a load set. Now we will see how easy it is to alter the applied floor loads. We will unlock the model and return to the Define Shell Uniform Load Sets command. Let's say that for some reason we wish to add a load value of 20 pounds per square foot to the dead pattern for the residences. If we return to the display of loads, we see that the dead load pattern now shows a 20 pounds per square foot load at each of the residences. Thus, once the load sets have been assigned, it is a trivial process to revise the applied loads to the floors. By simply altering the load set, we can change the load on every floor object to which it is assigned. This is obviously a very powerful capability when dealing with multi-story buildings or buildings with complex floor loading layouts, where reselecting floor objects and reassigning the loads can be a time-consuming task. This concludes this tutorial on defining and assigning shell uniform load sets.